our first official lesson in Algebra 2, we're going to cover algebraic expressions, and this lesson is split into two parts. So this covers 1.3 Part 1, or A, which is just evaluating algebraic expressions and then simplifying them. So a little bit of vocab here at the beginning. When you have 2 to the 5th power, we know that that means 2 times 2 times 2 times 2 times 2. So it's just a shorthand way of saying this very lengthy writing. And the base is the 2 and the exponent is the 5. So you could write 2 times 2 times 2 times 2 times 2, or you could do 2 to the 5th power on your calculator, or even better yet, if you knew that 2 to the 5th power was 32, you'd be able to evaluate that. We can do the same thing with monomials that are variables. So here we have x times y times x times x times y. So if I look at how many x's are being multiplied together, there's 3 of them, so that would be x to the 3rd power, and then y times y is y to the 2nd power. Order doesn't necessarily make a difference in that question. You could write the y's first. But, sorry if you can hear that. Typically we go in alphabetical order in math. So here, we're going to think of 4x as one term, and I notice I have 3 of them. But I can't just write 4x to the 3rd power like this, because both the 4 and the x are multiplied 3 times. So in order to signify that there's a quantity, it's 4x in parentheses to the 3rd power. And then same thing here with the 3y's twice, so that would be, this guy right here would be 3y to the 2nd power, again in parentheses. Yes, there are ways that we could simplify that, but I'm not going to worry about that right now. So here, 6n, but we got 4 of them. So this is quantity, 6n to the 4th power, make sure that's out of the parentheses. And then subtract 3 is not part of that quantity, so we're just going to leave that off to the side. Parentheses, extremely important. When you have -3 in parentheses raised to the 4th power, that means you have 4 -3's multiplied together. So if you think about the positive and negative rule, when you have an even number of negative signs multiplied together, your answer comes out to a positive. In this case, it's positive 81. However, if you write down -3 to the 4th power without parentheses, this right here really means a negative, or a -1, separated from a bunch of 3's multiplied together. So this is 81, and then throwing a negative in front of it gives you an answer of -81. A very significant difference. So often I get kids saying, oh, my calculator gave me the wrong answer. Well, no, what happened is user error and you typed it in wrong, so we got to be careful. Alrighty, moving along here, we're going to be remembering some order of operations. Please excuse my dear Aunt Sally, or PEMDAS, is a couple of ways that we can remember the order of operations. So parentheses are always done first. You have to be careful though, because sometimes there's what we call implied parentheses in math, where things are grouped, but they don't physically write parentheses, and I'll show you when they'll show up. So here, if we're doing this without a calculator, which is a skill that we need to kind of brush up on, -2 plus 5, that would be done first. So -2 plus 5 is a 3. So now we have -4 has not changed, plus 2, still that, and then times 3 to the 2nd power. So after parentheses, you look at exponents. So this is the number that is being raised to an exponent. So 3 squared is 3 times 3, which is 9. So now we have -4 plus 2, but it's being multiplied by a 9 now. And then multiplication would come next. So we multiply 2 times 9 together and get an 18. And then -4 plus 18 is 14, which is our final answer. Now, I don't want you to count on this for the rest of your life, because you should be able to do this in your brain without a calculator. However, if you were to just type exactly this in a calculator, you're also going to get the 14 as an answer, because your calculator does order of operations. The trouble is, sometimes we talked briefly about implied parentheses. You have to know when to use those parentheses on your calculator, and we will come back to that in a moment. Alright, so here, if you are doing this on your calculator, you would just type it in, but you know what, for fun, let's do it without the calculator, starting with the parentheses. So right here in the parentheses, 2 minus 6 is -4. So this is a -5 squared plus 3 times -4 squared. So now we have some exponents to look at. Right here, 5 squared, that is an exponent problem. It is not negative squared though, so I'm not circling the negative part. Here, however, we do have parentheses, so see the big difference here. So 5 squared is 25, but if I throw a negative in front, this is a -25. That's not what I wrote though, let's try that again. -25 plus 3 times, and then negative 4 quantity squared is a positive 16. Then I would do some multiplication next. This is a, 48, and then negative 25 plus 48 is 23. Again, yeah, we could have done that on our calculator, but it's a good option that if you don't have a calculator, you can still do this in your brain. Here there's no parentheses, there's no exponents, so you have to do multiplication first. So you actually have to do this guy right here first. That's a 20. So you have 3 plus 20 minus 4, and then working from left to right, all in one step actually. 23 minus 4 is, what, 19? There we go. So this is the tricky one. When you are evaluating, that's a fancy way of saying plugging in, or substituting is the other word we use. So here we have an expression, and then I'm telling you that x is going to be negative 2. You can evaluate that by plugging in negative 2 everywhere you see an x. So what I would like you guys to get in the habit of doing is writing what I call the skeleton of your expression, which means instead of x, I remove all the x's and I put big empty parentheses in place of where the x was. And then since they say x is negative 2, that's what I put in place of where the x was. And then you have a choice. You can either go on your calculator and type in exactly this with parentheses and everything, or you can use order of operations to figure out your answer. I'm going to kind of do order of operations in my brain here, starting with exponents, because there's nothing to do within the parentheses, but the exponents will have to happen next. So that's a positive 4, so we have negative 3 times a positive 4 right here, minus, well, let's see, negative 5 times negative 2 will be a plus 10. And then we have a plus 7 over here. So what? Negative 12 plus 10 plus 7 is 5? I think. I should know. I'm the teacher. I should know. All right. So again, yeah, you could just type it on your calculator. But what we will find out is that if you type this on your calculator without using these parentheses right here, you're going to get the wrong answer. So don't be so dependent on that calculator. A little more vocab here. We have 2x plus 4, that is a algebraic and algebraic expression. 2x and 4 are the two different terms in that binomial. 2 is called a coefficient. So if you have a number in front of a variable, it's called a coefficient. And then 4 is called a constant. A constant would be a number in an algebraic expression that is constantly the same thing because there's no variable attached to it. Sometimes you have algebraic expressions that are not in their simplest form. So like for instance here, 3x and negative 2x, we could smush and combine together to give you a 1x, which I'll just write as x. And then 7 plus 8, better known as positive 15. So that's called combining like terms, also known as simplifying, and another skill that we're going to have to use quite a bit in Algebra 2. Alrighty, so I'm going to kind of, oh, this is the end, so we'll keep going here. We're going to combine like terms. So 7x plus 4x is 11x. Notice I didn't say x squared. We're not multiplying them, we're just adding them together. Here on number 2, the only like terms that we can combine are the n squareds. So I have 3n squareds minus 1n squareds. That gives me 2n squareds. And then plus n. There's no like term to combine with that, so that's your final answer. Order does not matter. However, this is what we call standard form, which means it's going in decreasing exponential order. So the largest exponent term comes first, and then it decreases from there. All right, here we're going to use what's called the distribution property, which is really just multiplying. The 3x is going to get multiplied by each term in this binomial. So this time you do have to worry about exponents. 3x times 8x is 24x squared, because that's x times x. 3x times 6, this becomes a negative 18x. Again, order doesn't necessarily matter, but I like to write my answers in standard form. Here at number 5, you have some distribution, and then we're going to have to follow it up with some simplifying after that. So 4x times 5x is 20x squared. 4x times 4 is a plus 16x. And then this minus 18x is still off to the end of the problem here. So now I notice we have some like terms. The negative 18x and the 16x can combine to a negative 2x. However, that did not combine with the 20x squared. So my final answer is 20x squared minus 2x. If you have that written down in a different order, that is okay, as long as the negative sign is in front of the 2x term. All right, similarly here you have distribution, but you have two sets of distribution. Now be ultra careful back here. This is a negative 3 that you're distributing, so watch out for that part. This becomes a 2x plus 2. And then negative 3 times x is negative 3x. Negative 3 times negative 4 is a positive 12. That double negative distribution really messes with kids, so be careful. We have some like terms to collect. 2x minus 3x, mushing those together, that gives me a negative 1x. And then positive 2 plus 12 is plus 14. Order does not matter. I like standard form order if possible, so I'm going to leave it like that. Alright, next question. Some more distribution. 2 levels here. 4x minus 8, and then plus 3x plus 12. No one's going to like that answer, though. That is not simplified. So let's collect our 4x and 3x together. That's a 7x. And then negative 8 plus 12, better known as plus 4. Beautiful. And then finally here we have, I can't read what I have. There we go. I'm going to distribute the 6x. I'm going to draw my arrows underneath, though, if you don't mind, to here and here. And be careful, you're distributing a negative 7 here and here. So this algebraic expression becomes 6x squared plus 30x, and then negative 7x. Last term is the trickiest one, though. Negative 7 times negative x squared is a positive 7x squared. So now we're going to have to go back and find all of our like terms. I'm going to start with the x squared terms. Looks like we have 13x squareds. And then 30x minus 7x, which is plus 23x. Any order, doesn't really matter as long as you got the right coefficients with the right terms. Alright, so we're going to stop that lesson there. The next video is going to cover 1.3 part 2, or B, whatever we ended up calling it, which involves algebraic expressions with word problems. So go visit that video if that's what you need.